So I remember when I started learning this idea and we started off with the K, I didn't realize that we were going to go into all these different kinds of subscripts, and I just really tended to not pay a lot of attention to subscripts. But I want to point them out so that you can know what you're talking about. And there's one scenario where it actually really does matter if you're talking about one specific subscript over another. So when you very first talk about equilibrium, this is like the generic, like the most generic way to talk about equilibrium, the EQ standing for equilibrium. So any equilibrium is just like a catch-all term. They would be like that KEQ. Now it's not super clear if we're talking about concentration or pressure or what, but it's just an equilibrium. It's a catch-all kind of a term. And then underneath that, we have all these other types. So under KC, and I should have these scooched over because they actually are all types of KC. KC stands for concentration. And so it's when that ratio, and the ratio is always the products over the reactants, they're all multiplied times each other. But it's when that ratio is a concentration unit, and more specifically, it's when it's the molarity unit. And then for Kp, that stands for pressure. And then again, this is the pressure, and it's all products. And the pressure, all the reactants, all multiplied times each other. Now, within types of concentration, we have Ka, Kb, and we have Kw. Now, Ka stands for acid, Kb stands for base, and Kw stands for water. And this is a specific value, and this particular value at room temperature is why we have a pH scale that goes from 0 to 14 and not like 0 to 5. So that number is actually really, really specific and important, but you will spend a solid week just doing all kinds of, we call them ice charts, with this one, and you're going to have to be able to tell them apart. For this one, it's going to be making H3O plus. In one of the products, there's going to be other stuff on the products, it doesn't matter, but if it makes H3O plus, it's a Ka, and if it makes an OH minus, it's a Kb. Now, still under the realm of concentration, but they're kind of their own little entities over here. We have this one, so it goes around to here. This stands for solubility product. And this one actually describes how well something dissolves in water. And this will be after you get through all the Ka, Kb, Kw stuff. You'll have a lesson on KSP. And then we actually don't cover the Kw in this class. The K stands for the formation value. And this one is going to be specifically these, they're metal complexes typically. And it's a type of, they have brackets, but it's transition metals are what you're going to find in them. And some Gen Chem classes do cover them. They follow the same principle of products of reactants. You only put in things that are in concentration. You don't put in liquids or AQ or anything like that. But those are the different K units you're going to be seeing coming up.